Okay, for this lesson, we're going to take a look at how to use what we reviewed from factoring polynomials in order to actually solve quadratic equations. So we need to start by understanding the zero product law. So, if the equation x minus 3 is equal to 0, then when I isolate x, it is only true if x is equal to positive 3. If x plus 1 is equal to 0, I'm going to have to move the positive 1 to the other side, and it's only true if x is equal to negative 1. The equation x minus 3 times x plus 1 would be true if x was 3 or if x was negative 1. The equation 2 times x minus 3 times x plus 1 is true if x is 3 or if x is negative 1. For the equation 2x times x plus 1 is equal to 0 is true if x is equal to 0 or x is equal to negative 1. This is true because of the zero product law. The zero product law states the following: if the product of a multiple factors is equal to 0, then at least one of them has to be equal to 0. So if a times b is equal to 0, then either a is equal to 0 or b is equal to 0 for this to be true. When we're completing the work, following through the factoring processes, then I'm going to use the zero product law to solve what x would be if 2x plus 1 times 3x minus 7 was equal to 0. So the first thing, I have two factors here, 2x plus 1 and 3x minus 7. When I multiply them to get 0, either the one on the left, the 2x plus 1, or the one on the right, the 3x minus 7, has to be equal to 0. So the 2x plus 1, if it's equal to 0, then 2x would equal negative 1, or x would equal negative 1 over 2. In the second case, if 3x minus 7 was equal to 0, then 3x would equal positive 7, or x would equal 7 over 3. You can see that one of them has been verified already. If I have 2 times negative 1 over 2 plus 1 times 3 times negative 1 over 2 minus 7, well, this was 0 when I balance out the left-hand side times 17 over 2, and as soon as I multiply that 0 in, suddenly I know it has to equal 0. If in the second case x is equal to 7 over 3, then I would say that 2 times 7 over 3 plus 1 multiplied by 3 times 7 over 3 minus 7. Or when I take 2 times 7 over 3, 2 times 7 is going to be 14 over 3 plus another 3 over 3. This would give me 17 over 3. 3 times 7 is going to give me 21, divided by 3 is 7. 7 minus 7 is 0, which means that this is going to balance out to 0, or the right side of the equation. So this equation would work if x was equal to either negative 1 over 2 or 7 over 3. An equation is solved by stating the values of the variable which makes the left side and the right side equivalent. These values must satisfy the equation, like the case that we just saw. Values of the variable which satisfy the equation are called the roots of the equation. The roots of the quadratic equation in example 1 are either negative 1 over 2 and positive 73, which we've already seen. If I consider the equation x minus 2 times x minus 4 is equal to 0, this is true if x is equal to 2 or if x is equal to 4. Now, we say or because it can't equal both 2 and 4 at the same time. We can only substitute in one variable or one value for x because it has to be the same value I put in for the same variable every single time. However, since the equation is satisfied by either x is equal to 2 or x is equal to 4, then the possible roots are 2 and 4, which means that either one of them are possible solutions that could work. So, like it says here, solve the equation x minus 2 times x minus 4 is equal to 0, x minus 2 would equal 0, or x would equal 2, or x minus 4 is equal to 0, x equals 4. The answers are if x equals 2 or x equals 4, which means that x would equal 2 or 4. The roots would be at 2 and 4. So, if I'm solving the following equations, well, I could say that either x minus 7 is equal to 0, or x plus 8 is equal to 0, which means that x would equal to 7, or x would equal to negative 8, which means the answer is x is equal to either 7 or negative 8 for this to be true. In the second case, my two factors are x and x plus 10. So I could either say that x is equal to 0 or x plus 10 is equal to 0. X is equal to 0 is already stating an answer. X is equal to negative 10 would be the other possibility. So I could say that x is equal to either 0 or negative 10 for this equation to work. If I'm determining the roots of the equation 2x minus 5 times 3x plus 2 is equal to 0, then I'm going to state that 2x minus 5 is equal to 0, or 3x plus 2 is equal to 0. Here, 2x would equal 5, or x would equal 5 over 2. For the other one, 3x would equal negative 2, or x would equal negative 2 over 3, which means that the roots are 5 over 2 and negative 2 over 3. If I'm solving quadratic equations written in general form, well, the first process is we'd actually need to factor it down to figure out what our factors are that could possibly equal 0. So if I have x squared minus 9x plus 20 is equal to 0, I'm going to factor this polynomial down. And because the coefficient for x squared is 1, I just need two numbers that have a product of 20 but add up to negative 9. It's going to be x minus 4 and x minus 5. Which means that either x minus 4 could equal 0 or x minus 5 could equal 0. So x would either equal 4 or 5, which means the roots are 4 and 5 for this equation. I'm going to follow the same steps for all the ones in example 4. The first thing is I need to factor. So I'm going to start by factoring it down and saying that x minus 7 and x plus 2 is equal to 0. So x minus 7 is equal to 0, or x plus 2 is equal to 0. X would equal 7, or x would equal negative 2, which means that x is equal to 7 or negative 2. For example B, I'm going to factor using my different squares, and I'm going to get 2x plus 5, 2x minus 5 is equal to 0. So either 2x plus 5 equals 0, or 2x minus 5 equals 0. This would be 2x is equal to negative 5. This would be 2x is equal to positive 5, or x is equal to 5 over 2, negative 5 over 2, or x is equal to positive 5 over 2. How can I state this? X is equal to either positive or negative 5 over 2. It doesn't matter if it's a positive one or the negative one, it's still going to make it balance out. Now the nice thing is, when I have an equation, if I have a common factor that is not a variable, like in this case a common factor of 10, I can just start by dividing all the terms by 10. Well, this is going to give me x squared minus 9x is equal to 0. I don't need to keep that common factor in brackets on the side because I just divided it out of both sides of the equations, just like if I was solving. Now, the common factor of x, I do need to keep because that's a variable I'm solving for. So I'm going to take an x out and have x minus 9 equals 0. So either x equals 0 or x minus 9 is equal to 0, which means that x would equal positive 9 in this case. X is equal to 0 or 9. In example D, I'm going to start the same way. Divide all the terms by 10, and I'm going to get x squared minus 9 is equal to 0, and this I'm going to factor using a difference of squares. X plus 3, x minus 3 is equal to 0, which means that either x plus 3 is equal to 0 or x minus 3 is equal to 0. This would be x is equal to negative 3. This is going to be x is equal to positive 3, which means that x is going to equal plus or minus 3. When solving a quadratic equation by factoring, the quadratic equation must have all the terms on one side and 0 on the other side. It is usually easier if we leave x squared as a positive. I find this almost all the time. I want my x squared to be positive, so I'm going to move it to whichever side of the equation will make that happen. So for example A, the first thing I'm going to do is I'm going to multiply this out. I'm going to get x squared minus 4x is equal to 5, or x squared minus 4x minus 5 is equal to 0. I'm going to factor this by inspection. X minus 5 and x plus 1 is equal to 0, which means that either x minus 5 is equal to 0 or x plus 1 is equal to 0. X would equal 5 or x would equal negative 1, which means that x is equal to either 5 or negative 1. In the second case, because x squared is negative, I'm actually going to move everything to the right-hand side, and I can still solve it. 0 is equal to 3x squared minus 13x minus 10. Well, this one I'm going to have to do by decomposition. I'm going to take the 3 times negative 10 and get negative 30, and I need two factors of negative 30 that add up to negative 13, and I'm going to use 2 and negative 15. So I'm going to say that 0 is equal to 3x squared. I'm going to split up that negative 13 into plus 2x minus 15x and minus 10, factored by grouping, and I'm going to say x and 3x plus 2 and negative 5 and 3x plus 2, or 0 is equal to 3x plus 2 and x minus 5. So my possibilities are either 3x plus 2 is equal to 0 or x minus 5 is equal to 0. This is going to give me 3x is equal to negative 2 or x is equal to negative 2 over 3. This is going to give me x is equal to 5, which means that x is equal to either negative 2 over 3 or 5.